to see if I can get the thumbs up for the streams running. Yes, it is. Right, thank you everyone for joining us for the last session. As I was just saying to Roger, this feels like the graveyard shift, but it really isn't. We're going to keep you here for as long as we can. So I'd like to introduce Dr. Raja Naeem Akram. So he is the CEO and co-founder of Seclea, the associate professor at the University of Aberdeen, worked at user-centric security solutions, user empowerment, and generally dealt with technology for the last 15 years. His current focus is on the negative impact of artificial intelligence and how to minimize that. So really interested in this sort of quite thoughtful piece on artificial intelligence, governance, risk, and compliance. So, Raja, over to you.
Thanks a lot. Let me see whether this works. So I just have to press the, no, I have this pointer. That's the pointer. This node tracker thingy. Okay, the keyboard then. Guy was actually talking about it in the email, and also he mentioned in the while we were standing here about the recent Google news about the chatbot. I'm not going to go into long discussion. If you ask me, is that chatbot sentient? I will say no, it's not. Because the way the chatbots are designed, chatbots actually automatically exhibit that kind of a behavior if you give them enough textual data. And this is not the first time that kind of a behavior is seen. I think 6 years ago, a small AI machine actually beat the Turing test, which was much more difficult to beat than the one thing which the person has released. On terms of the news, there was a much bigger news which came out of Google's AI division, which nobody paid attention to. And that was actually the Google's ethics lead. She resigned because she said that most Google's algorithms are unethical and they actually discriminate against minorities. And instead of that becoming a news, she was actually fired, or she actually decided to leave, whatever way you want to actually take it that. So today, we're actually going to talk not how AI can help us, but how AI can actually create some issues. So, and how we can actually deal with those issues. I'm not actually saying AI is bad, so forget about it. No, AI actually has some issues and we can fix them. It's the same thing. Technology had issues and we forgot about cybersecurity for first 20 years of technology. And then by the time we remembered it, technology was already too far ahead of us. So, and my background is in cybersecurity, just to be in case. So had a PhD, I think a long time ago from Royal Holloway University of London on information security. Mostly worked on how you can actually put multiple applications, payment applications, card applications onto your mobile phone before the mobile phone thingy became popular. And this is actually before smartphones. Nokia actually had a phone on which you can actually put multiple cards and applications on there. It actually had a secure element. By the time they could release into the market, smartphones came in. So then smartphone took over. Built actually in Edinburgh, I worked for a company building online fraud detection platform back in 2010, and was using AI before AI was actually, let's say, a hip thing to do. Worked on data provenance. This is before GDPR, and how users can control their data moving across different organizations, and how they can view what the operations are being performed on that data. And then the GDPR came and I said, leave it. It's now become boring. Do something else. If you fly and you see wireless in the aircrafts, so one of the early projects on those I worked on, and actually that project was way further ahead, that even you can actually move all the, other than flight controls, every other network system in an aircraft can be moved into wireless. And it is actually most Jetstream aircrafts now actually are flown by, not flown by wire, but flown by wire, but every other network is wireless. So the last one actually which really excited me was how we can actually create transparency around organizations. And this is actually where the idea came, is that most of the AI applications, they're not transparent. We think of them as a black box. So you put some data in, something comes out, we don't understand why AI is making that decision. And that actually led me to more of this concept of we need to build technology for good, especially in the AI era, because AI actually has huge potential and equally huge negative impact. If you want to know more, this barcode is there, scan it, it just goes to LinkedIn. So this is the agenda for today. Why there is an AI regulations are coming, and what impact that will have, especially on the managing the risk from the AI, and then how we can actually build some solutions that can actually help us deal with both regulatory compliance and risk management. So this is the big promise. So every article which I have read on AI, they which actually let's say trying to sell AI, have one of these three things. It will increase your productivity, profitability, and it's a ubiquitous technology. You can use it anywhere in the world, and it is running 24/7. So you don't need to worry about anything. Like even chatbots. Chatbot is basically a customer service thing which is running 24/7 without humans being involved. So this is actually what the promise is, and this is something which is hidden. AI is actually shown to exhibit bias and discrimination. There are so many cases. Like in 2021, there were more than 1,300 cases of biased AI in production. I'm not talking about in experimentation, in production. The biggest one is the Apple credit card, because Apple credit card gives 10 times more credit to male applicants than female applicants with the same background. And they are currently being investigated, and uh, maybe they get fined for that. Then Amazon's hiring algorithm, it actually predominantly favors black men than any other ethnic group because of the background. Because the same thing with the healthcare, um, white Americans are given priority over any other ethnic group in healthcare services. Transparency. When in the Apple credit card case, when they were actually asked why your algorithm is doing that, the answer was algorithm makes the decision and we don't know. And after 1 year of investigation, they found out that there was, when they were actually building the AI model, they got some data from the bank, and they said, okay, we don't want to make this algorithm biased against females. So what was the decision to do that? So what the solution was, just delete the column that says gender. So if we don't have that column, the model will not become biased. And forgetting about that, gender is not just a column, it actually also has a relation to many other things in other part of the data set. And most prominently is the salary values, salary scales in America. So females are paid for less for the same kind of job historically, and that historic fact was in the data set. So that's why when the model trained or learned, even there was no column that says gender, it was still biased against gender. Uh, and it took them a year to find that problem because there is actually no transparency and traceability in AI model development. If you buy a model today, you say, okay, this is an application, it helps me do firewall protection. And say, can actually I have a full traceability of how this model has been designed or developed? You won't get that. And what about if a designer has made a decision which is going to be wrong in future? What about if the data sets are slightly being changed during the operations, and what behavior it will exhibit if the data set is being changed? Recently, I was reading a paper, it is not published yet, it's still in peer review, in which they shown that only like say, a KB or 2 KB of data change can drift a model enough to actually be a difference between a diagnostics being a cancerous cell and non-cancerous cell. It's not huge amount of an attack that, oh, they need to pump in GBs of data to change the model's decision, model's drift. It can be a very small amount of targeted data. So we don't actually have transparency. We don't understand how the model internally is working. That's the problem at the moment. And then once we have done the first two, let's say there is actually a solution to first two, then we come to the third problem. Explanation. How we can explain our models and its decisions, especially in layman's term. Uh, if there are actually standard AI models, which is like a decision trees is just a representation of human knowledge into a graph. That's very simple to explain. You can draw it, but that's not most AI algorithms are. Especially the good ones or the exciting ones, the neural network ones, the one which actually the Google talks about, the Google chatbot, it's a neural network. These are the exciting models. And they actually have so many hidden layers. Like they might actually have millions of hidden layers that nobody has seen. And even model doesn't actually retain those hidden layers. Like it's a state, it calculates, and then it destroys that state. And then it calculates the next state based on the previous knowledge. And there might be millions of these states which are behind the final state on which the model is currently now operating at. So that is what making the decision, but we reached this point because of millions of previous discarded model states. And these actually have an impact on this. And we don't actually have the tracking to make the connection between these hidden states and the visible state. So, and the last one is accountability. We don't actually have any tools to audit AI. So if thing goes wrong, we can't go back. So there is an example, a know your client application. So one of our partners, they were building know your client application using AI, and they're actually sourcing data from more than 160 different providers. Now, this data is not in their control. They're only one provider among 160. So there are 159 external providers which can actually feed data that might be malicious, might be incorrect. And the model is learning on that. And later on, if the model makes a bad decision, they don't actually have the ability to go back and see which data source was the reason why this model actually evolved in that direction. So there's no accountability of going back. So these are the four minimum problems. And these are the four problems why 80% of all the AI projects fail. So globally, Forbes done a survey and they found out that 80% of the projects fail. They're amazing performance, but the problem is they can't meet any of these four requirements. And when this problem became actually public, as usual, governments jumped in. And now there are more than 87 AI frameworks and regulations currently under discussion. And it even includes China. So if China is actually regulating AI, then you know something is wrong. So, and the most advanced or the most, let's say, matured AI regulation is basically the European Commission's one, Artificial Intelligence Act. There are actually in UK currently people studies done, and they might actually go with that AIA, the Artificial Intelligence Act, than anything else. America is actually doing the same thing. So if you actually have a healthcare device, even if 1% of that healthcare device actually has a software component that is based on AI, they have a separate regulation called a software as a medical device regulation by FDA, and you have to go through that as an approval process to launch your solution into America. And one of the companies I was talking to last week, they said all these data scientists that developed the model, they left the company and the FDA asked them, why you made these decisions? And what about the models which failed in your experimentation? Could you please provide the record of all of those things? And they don't have any of those records. So what they did, they scrapped their designed model and then started building a new model and said, this time we will put all the records in place. So the 5 years of work actually have to be redone again. So regulations are coming on AI, and we will talk about the details of those regulations, especially the Artificial Intelligence Act one, which I'm going to go into a bit more detail than any other regulations. But if you are interested in any other regulations, more than happy to talk about them also, because that's what is interesting. But AI, Artificial Intelligence Act, is the most comprehensive one in all of them. So it has already been proposed. The draft version is currently circulating. They're doing public consultation. By the end of this year, it will actually get approved by the parliament. And this is the overall structure. The Article 5, if you're actually doing something very, very nefarious, that actually applies to you. That if you want to build AI that can actually influence people's decisions in a negative way, like for example, if you want to build a let's say chat bot, which you want to run it on Twitter for political purposes, that's actually you fall under the Article 5, which is prohibited by this regulation. Other than that, it doesn't actually prohibit you. The applications on which this regulation applies on is the high-risk AI systems. The definition in a very simple way, if the data which is used to build that model relates to human, or if the decisions of the model impacts human. So if human is anywhere in the equation, you are basically a high-risk AI system. So if you're actually a network monitoring tool and you're actually monitoring human traffic, on internet, then you fall under the high risk AI applications. But if you're actually monitoring IoT traffic in an industrial ecosystem, then you might not actually fall under the high risk AI system. But the whole regulation actually has as an annex in which they detail all the applications they think fall under that, and that annex is actually going to be updated regularly. So if we actually go into the high risk side, there are a few things which they require. So transparency is the very first thing they require, that your system should actually have full recording. And then performance, record keeping, technical, and then we go to the quality management and risk management. We go into more details into each of those sections later on. And you see that cybersecurity on the right column, cybersecurity is basically fall under performance. Because in these regulations, they don't put cybersecurity separately. They say cybersecurity is basically a component of AI performance. Because sometimes you actually work, some of the attacks on the AI is on making the performance go bad. And performance in the context of AI is not how fast it makes the decision, it's to do with how accurate it makes the decision. So we talk about accuracy and robustness as a performance metric rather than speed. So that's why cybersecurity is actually under the performance, not in any other headings. So what is the purpose? The purpose was actually basically too much public pressure, especially on the bias side. There were too much bad press for the AI, and organizations want to deploy AI because it makes things much, much easier to do. And instead of catching up to do with the GDPR and all the other regulations, this time the European Commission decided, let's put the regulations first before the wave comes. So, and the wave is coming. That's for sure, because the current estimates is that by the end of 2030, majority of the software, any form of software, whether it's in the cloud or whether it's actually in your devices, they will actually have some components using AI. So the wave is coming, and they're actually trying to regulate it before it comes. So it's again horizontal minimum baseline, and it is only focused on the high risk AI applications. Any application which is not high risk, you can actually still go for the compliance, but you actually don't need to do the full compliance. You can just do the code of conduct thing. One of the applications which was really weird for us to actually look into as a compliance perspective was the lighting and electricity usage in a building, because we thought that that doesn't fall under the compliance. That's more of the non-high risk AI applications. But when we actually looked into the data they were collecting from the power sockets, from the light usage, especially from the power sockets, because they can tell whose device it was, whether it was a laptop, or if it was a laptop, whose laptop it was, whether it's a mobile phone charging on that power socket. So then we actually went on to, you guys actually have to be fall under the high risk AI system. Because sometimes on surface, some applications might look like that they fall under non-high risk AI, but you need to look into the data sets they're collecting. Because this is the data set that actually tells you whether there's any human identification possible with that data set or not. And it actually applies to, even if you're just a user. Providers, definitely, if you're building that system, great. But if you're just using that system, you might actually also fall under that. And especially if the output of your system, you're using it to actually decide something further, which is a really weird thing. This actually also creates some confusion that if I'm actually an individual consumer using a mobile app, will I fall under that? So there is actually, European Commission has to figure that thingy out. But the first one is very clear on, if you're building an AI application, then definitely you actually have to comply with this regulation. And one thing which I liked about this regulation was, at least they put an annex with every possible permutation of how AI is actually identified in the market. Instead of just simply saying AI, because when I say AI and somebody, if you're actually in the academic community, you will say machine learning is not artificial intelligence. Artificial intelligence is a completely different thing. But this time what they went in, they said, okay, here is a list, guys. Everything in that list falls under the AI. So machine learning, supervised, unsupervised, reinforced, logic-based, representation, knowledge-based, you name it, they put it there. Even to extend statistical approaches. they put it there. They sort of, banks might actually get away with by simply saying, "Oh, this is actually a statistical approach rather than a AI." You said, "No, no, you actually also fall under that." So even if you're building a Bayesian estimation or statistical approach in your rapid trading algorithms, you are basically an AI algorithm in this under this definition. So this is the application which are prohibited. You can build it. They're prohibited. You can build it, but you need to get a prior approval from the commission before you go on to and build it. Especially in the last bullet point, you can't actually build a real-time remote biometric identification system to be used in public. Even for the purpose of law enforcement. If law enforcement want this kind of a service, they need to get a prior approval from the European Commission, and then they go on and build it. Most probably that's what is going to happen, and they're still going to build it. But you still actually fall under, if you get a prior approval, then you still have to go through the regulations nonetheless. So this is the high-risk AI system, couple of examples where they can be applied. In more detail in the annex, actually, they put cybersecurity applications in there also. This is actually very high level for the different applications. That's actually, this is more interesting stuff. So in GDPR, you actually had a 4% of your worldwide annual revenue, annual turnover. In this regulation, they put 6%. So if you are actually not compliant with Article 5 or anything around Article 10, then you fall under 6%. Other than that, 5 to 10, then it's only 4%. And other thing is actually 2%. But this actually putting much more stringent, saying we are serious about this thing now. And one thing which they put in is that the whole process, the whole compliance is from risk management perspective. And why it went for the risk management perspective. Bias is bad, as I started the presentation, that bias is really bad. But there are certain applications in which you need bias, especially in healthcare, because certain diseases impact certain ethnic communities more than the others. So you need to actually have biased systems. So then you actually go to the risk management side and say, I need to accept this bias because this bias is necessary for my application. And that's why most of the regulation requires that you actually create a risk profile first, and then in risk profile, define whether you want to accept the bias or not accept the bias. Like if it is about fairness in financial services or financial dealing, yes. But if you can actually say, I need to actually discriminate against postcode because certain postcodes actually they don't pay their credit cards back early, or insurance company might actually want to do that. But that actually has to be specified in the risk management side. And AI is actually going to make some bad decisions one way or the other. So don't think that AI is actually a silver bullet. It is never going to make any bad decisions. It is going to make bad decisions. It's the same principle in IT, garbage in, garbage out. Our data is not that good that we can say that AI actually will become really good based on that data. So it is going to make bad decisions. So you actually need to have some kind of a risk management system that is looking into the AI's behavior most of the time, or all of the time if possible, and see the early signs of that drift. Because it doesn't happen with the AI is that it is making good decision, good performance, and then suddenly bad performance. There's actually, the technical concept is called model drift. So it's basically slowly, the model is actually moving towards wrong decisions. And you can detect it early on. So they basically require in the risk management system that you have controls in place to actually detect that, and you don't actually go into the, let's say, foreseeable misuse side in future. One more thing which I liked about this one was that it's not a one-time exercise from the risk management perspective, because AI evolves much faster than anything else, especially if you're actually using the unsupervised learning. So just to actually explain, if supervised learning is that you actually set restriction parameters, and those parameters are defined by humans. Like, for example, you actually have a lot of X-rays, and you actually radiologist actually draws a circle and say only look inside that circle, and that's basically restricting the model to look only in that point. And then you train that model, and when the model is actually doing good, you lock it. Lock means that it will never learn anything new. That's called supervised learning. And unsupervised learning, which is more exciting in terms of, at least from the research perspective, is that you let the model learn even in the deployment. And the reason why you let the model learn in the deployment, so it can learn new behaviors which was not in the training data set. This is actually very, like, say, useful for cybersecurity, healthcare, financial services, and fraud prevention. Because not all types of fraud patterns will be in your training data set. Not all kind of the diagnostics information will be in your healthcare data set. Not all kind of like cyber attacks will be in your data set. So you need to actually allow the model to learn new behaviors, new things in the deployment also. And when you're actually going to do that, that means that every day there is something happening which might actually create risk, or the risk profile is changing every time it learns something new. So it's the risk management actually has to be more dynamic. It doesn't have to be static, especially in the unsupervised learning models. In supervised, yes, you can say, I learned, I locked the model, it's not going to learn anything new, and so I don't need to do risk management dynamically. But for unsupervised, you have to. So this is the same thing which I was talking about. You can define the metrics and then also probabilistic thresholds, that how far you can go out. This actually is used mostly in the healthcare space, that you actually, if there is a certain disease, give them, let's say, 1 tablet of paracetamol. But the model can actually learn, and it is shown in the experiment, that it found out automatically that if I actually prescribe 4 tablets, the patient gets well quickly than if we give them 1 tablet. So it's automatically moved to that 4 tablet prescription. And it inferred, okay, if I give them 6 tablets, it will be better. So you can actually put a thresholds around that, okay, you should not prescribe medicine beyond this extent. This is the maximum extent. And that's basically what they call it, the thresholds. To avoid model going into making decisions which might be helpful in short term for the patient care, but may be damaging in long term. So in healthcare, this is used a lot. They also use this a lot in trading algorithms. That sometimes the trading algorithms can learn and say, oh, I'm making more money, so let's put more money, more money. And it doesn't want that the algorithm end up just buying from other algorithms to the extent that the market gets inflated. So they're being required to actually put a threshold of how much they're buying stocks or whatever they're buying, or crypto assets. So they use thresholds. They're easy to actually explain in certain systems or certain applications, but they're very difficult to actually put in. For example, in cybersecurity, putting these probabilistic thresholds is very difficult to put in place, especially if you're actually looking into the intrusion detection systems, because it's difficult to quantify what is the normal behavior of an employee and what is not a normal behavior of an employee. Data governance, the only thing which I will add on to is a standard data governance. The only add-in thing in this regulation is that you have to specify how you got that data. So whichever data you're going to use for your training of your AI model, or the thing with the AI actually going to process, you need to provide its provenance. So how you got that data and what operations you have performed on that. Under what consent that data came to. There are actually instances in which AI actually can inference things which are not even present in the data. For example, we were in one of the projects I was working on in the railway industry, we took some anonymized data for passenger travel habits. And we got some non-anonymized Twitter activities. And most Twitter activities with tweets, so you can find the location also. And we were able to actually de-anonymize the traffic data from Twitter data. So if your AI algorithm is actually taking multiple sources of data, and one source which you said, oh, this is actually very like, sensitive and previously required, so I'm actually putting a anonymization, you need to actually also understand the impact of other data coming into the AI. Because AI might actually learn a pattern from the data set. Oh, this passenger is basically this person, so I know about this person. That means I can actually tailor the services for this passenger, which is anonymized to me. So you have to data governance becomes a bit more tricky in those contexts, in the sourcing of the data. Other than that, it's the standard GDPR kind of stuff. Technical documentation is the one thing which even the data scientists I work with hate a lot. Because the technical documentation says during your experimentation, like for example, in that Goldman Sachs case, Apple credit cards algorithm was built by Goldman Sachs. So in Goldman Sachs case, when they deleted the age column, they did not actually recorded that the age column, sorry, gender column has been deleted. And they also did not record it who made that decision to delete that column and who approved it. And that's what the European Commission's regulation require. You need to actually get that kind of approval. You need to actually get that kind of like recording. So all decisions you are making, you are recording it. So this is actually where the record keeping comes in, and this is where the robustness of the performance is coming in. So just to make sure, how many minutes I have? 5, 15. Oh, I thought I would only have 5. No. So I was talking earlier that in in AI, we should put accuracy, robustness, and cybersecurity together as performance metrics. And the reason we put it as a performance metrics is because majority of the attacks on the AI are not about, let's say, we're going to steal something from data out of it. The attacks are to, let's say, nudge the AI in a direction that its accuracy goes down. So it doesn't make that accurate decisions, or its robustness goes down. So that's the majority of the AI attacks are. Like, for example, changing the X-ray images, not to actually damage a patient, but to actually train the algorithm in a manner that tomorrow is like say, cancerous cell can also be detected as a cancerous cell. Training the AI in a manner with certain activities, network activities, that tomorrow when an attack will happen, the AI accepts that network activity as a genuine activity rather than a malicious activity. So that's actually the most of the time the cybersecurity comes into existence in the AI context. Application integrity, like I have seen this, oh, I can put a hash function around AI and we can just measure the hash function all the time and see whether its integrity is being changed. AI model, even when they're actually not attacked, they change a lot. And they change depending upon how much input data they're getting and what kind of input data they're getting. Because if you just to explain how AI model works. So AI model basically takes the data, creates extracts some parameters out of your data set, and then put a weightage next to that data parameter. Let's say when I'm actually going to approve a credit card application, I'm going to give 20% weightage to, let's say, age, 10% weightage to location, 5% weightage to color of the skin, 50% weightage to their salary. You should explain these kind of, AI actually build that kind of a matrix. Every time it makes a decision, it goes back and update that matrix again. Because it is, even if you actually have that lock and key and throw away kind of a model, it's still changing a lot. So putting simple hash functions and then tracking that hash over time, unfortunately in AI context, it doesn't work. Then there's a couple of concepts of like we can create a snapshot of a model at one stage, and then if something goes wrong, we can revert back to that snapshot. So basically taking a backup of our model. That works. I'm not saying that doesn't, that works. But basically you're also like forgetting the last 1 month, 1 year of knowledge which your model has learned. So first of all, you don't know when the attack happened. When you know the attack date, going behind before that will actually mean that you have lost anything extra knowledge. Uh, there is one more problem with AI is that the sequence in which the data enters a model also impacts the model learning. So the idea a couple of times it was explored that okay, model was really good in first 6 months. Then there was a 1 month of let's say bad activity in which some kind of an attack happened, and then the model got the good data for another 6 months. So there's only 1 month which is the problem. So can we just subtract that 1 month out of the model? Unfortunately, we don't actually have the let's say science or technology whatever to do that. What we can do is get all the data for the first 6 months and the last 6 months and separately train a new model and then put it back into production. That we can do, but we can't actually remove that 1 month from inside the training of a model. It is same thing is that if you raise a child and at some age you should treat him, sorry, you gave them some bad training, it's difficult to go back and remove that bad training from that child. It's better to have a new child. So, that's the same thing with the AI. And that's why and at small company at SME level AI is actually retrainable, it's easy, cost effective, but the at the lambda level which Google has done, that's very difficult to retrain because it costs a lot and getting all the data back is also problematic. So a new concept came is that, especially to the AI, because AI didn't actually have these kind of concepts before, and that was the quality management system for AI. And in the quality management system for the AI, they brought in many other concepts in. They brought in risk management. So risk management is actually a component of the AI quality management. Performance is one metric, and inside performance we have cybersecurity. Uh, then transparency, bias, fairness, explainability, record keeping, everything which we talked about. I think from the article 5 to 16 and then 18 to 50, all of these articles actually fall under quality management system. And quality management system is required to continuously monitor AI's behavior and its compliance with the regulation. Uh, because you might actually do a compliance, let's say, exercise at day 1. Day 5, the model is now in a completely different state and might not be in compliance anymore. Just a small example. You did a bias analysis at the data. You looked at the data and say, is the data biased or not? You found some issues with the data, and then you fixed those issues. You actually went and trained the model, and you forgot to actually check whether the model is biased or not. And you put that into production. So you are compliant with the data bias part, but you're not compliant with the model bias part. Okay, you did the model bias again. Good. But the model can become biased in production. So then you have to keep on monitoring all decisions made in production and then weight them with the bias metrics and see whether those decisions are biased or not. So compliance in AI is a continuous process. It's not a one-time, you can slice it, comply it, and then forget about it. So up till now was actually doom and gloom. And that's now actually I put my sales pitch. So yes, you can make AI fair. It's possible. Most of the state of the art to make AI fair and not fair and transparent both. These concepts comes from 1980s. It's a Nobel laureate. Our last name is Shap. So Shapley is mostly you can use Shap algorithms to do that. But that's actually not where we wanted to go. What we wanted to do, because the state of the art was, we trained the model for 6 months, we reach to a state, and when this state makes a decision, we explain this state. We say, this state says age is 50% important, that's why we made this decision. By why the age is 50% important is not explained, which is basically the past. So we actually, in our research, we actually went in and looked into the past bit and say, let's explain the model with this past context. Tell them, because you gave me this kind of a data, in the data, majority of the participant was actually of that age group, and that age group actually means that I put more weight into that. So that way you actually have more contextual explanation rather than just simply saying because age is 50% important. So we went into fairness. We provide full transparency. You can see every decision and why that decision is being made, and you can track it back to the design. It's not just actually the data scientist uh, action, but also how the data was actually inputted into the model and it's impacted the model evolution. And the same thing with the explanation. But the last bit is that if something goes wrong, you still have the tools to investigate what went wrong and then possibly fix it. Most likely not. You have to retrain the model, but you can still help them. And that's what the spin-out company from the university does. It actually provides that platform. It's called Seclea, and it provides that platform. And if you want to actually look more into all the challenges in AI and how quality management systems are required to perform, yeah, you can scan the barcode. It goes to this white paper. It basically explains all the quality management challenges which an organization might find themselves if they're actually adopting or developing an AI model, and how they can actually fix those challenges. So that's the end of my presentation. And if you have any questions, please feel free to ask. Thank you.
Thank you very much for this presentation. It was very insightful. In cybersecurity, we rely greatly on automation, and the big buzzwords are AI and ML-empowered applications for security reasons. If you were to give an advice to companies today, what would be sort of the key parameters that they should look at in order to evaluate whether these applications are actually providing the benefit and sort of sold opportunities or not? Like, what should we focus on in terms of their implementation?
So, but you're only looking from the benefits perspective. Benefits have to do with its performance. So
Yes.
if it is accurately detecting what it says,
Correct.
great, because that will give you the benefits. But what challenges it will bring in is what we talked about, how they built that application. So the people who actually say, okay, here is my application, it's really nice and shiny. You can say, okay, have you done the bias analysis in the data sets? Have you actually done the model analysis? Can you explain this model to me? Especially how it internally works. And if they come back and say, oh, this is actually our secret sauce, tell them, don't give me the secret sauce, just tell me its behavior. Because you can explain the behavior. Explanation of a behavior is basically we take certain points in your data set, we track them, and we actually build a relationship between them. For example, how a model detects there are two eyes and nose. Basically, there's an angle, you can make a triangle. I don't need to know what the code was doing, but on a conceptual level, I can say it's a triangle. So 1, 2, third point. You can do the same thing with the any time series data or tabular data. So they should be able to explain the model to you. And finally, the last bit, if you want to actually avoid any kind of a compliance issues, you can say, are you actually compliant with any future regulations which are coming? And it's not all about European regulations. There are actually UK standards also. Turing Institute has published a standard. Bank of England has published a standard. ICO has published a standard. At the moment, they're going with the standards, but all of the requirements for those standards are exactly the same as the Artificial Intelligence Act. So they don't actually water it down. They basically keep the same. So ask them whether they're compliant with that or not, because that will avoid you any kind of future issues to you.
Okay, thank you very much.
No worries.
Couple of questions actually from me. The first one possibly about, there seemed to be a great unspoken parallel between the AI Act and obviously GDPR. Do either of those call each other out, or is it just meant to be read in parallel?
In GDPR Act, there was actually a clause of explanation how you use the data and what analytics you're building on top of it. Companies actually found a trick, a loophole, and say, oh yeah, we actually just do this 5 things and get away with it. Originally, the debate in the European Commission was we're already doing it in the GDPR. We don't need a new regulation. We don't need AIA. But when they saw the activities being done by the AI companies, that they say, oh, we are GDPR compliant and we are not explaining how the model is built, how the model is doing. The only thing they was doing was you take the data, put in the model makes this decision. That's it. That basically was one of the motivators why they went for a second regulation. And there's actually third one also, Digital Services Act. I didn't actually talk about that. Digital Services Act actually then built on top of this. So if you're actually going to, from a company perspective, you have to do GDPR minimum. If you have an AI component in your company, then you have to do Artificial Intelligence Act. And if you provide any kind of a service on the internet, then you actually, or consumer service, then you need to move into the Digital Service Act, which also requires AI to be explainable and not fair. It's what the Chinese regulation says. If you're recommending somebody to do something, like even to buy something, like even Spotify recommending me to listen a song, they should explain to me why they're actually recommending that song to me. And it has to come across as they're not manipulating the market. They need to explain that. That's the DSA. And China actually went that first than the other one around. So it is on top only if you're actually going for the Artificial Intelligence Act. But if you actually say, I have done AI, and if I am compliant with the AI Act, then I don't need to do GDPR? No. You still have to do GDPR because GDPR has way more other elements which are not related to the AI.
Yeah. My second question is, this is probably the stuff of science fiction. Do you ever see that AI would ever reach a point whereby it has its own ethical conundrums and whether or not it could exist and has its own rights?
So there are research projects that are looking into putting ethics into the AI models. So AI, it's again, it's just like teaching child how to behave in the society. So the same thing is happening. But the question comes, is that they know it or they're just doing it because there's a rule set? Because the way the currently is being done is by creating a rule set, and the moment they actually hit that, it's a if condition, they go back. For example, in climate modeling, don't kill humans is one of the rules. So, because there was actually a climate model that actually decided that the best way of surviving is killing half of the population on the earth. And then they put a rule in there that that's an ethical principle coded into it. Does AI understand ethics itself and it can create ethical norms of its own? That's way far ahead. That's actually called AI Generation 3, which we are nowhere close to. Maybe Elon Musk's brain thing you might be, but not for normal academics.
So if for GDPR we need to register for ICO, right? A company should register
Yeah.
at ICO, and in case a company thinks of put in AI, a simple program, maybe a chatbot or something, then should we register at some point?
Yes.
Okay.
So there is going to be separate authorities. It might be ICO,
Okay.
but that's actually individual country has to decide. So one of the articles in there is to actually identify an authority, and that authority will then actually, you report to that authority in that country. European Commission is also creating a board. It's called AI board, which will update the regulation and what is fall in the regulation, what falls outside the regulations every year. So, and the reasoning for it is that you can slightly tweak and that's a neural network and say, oh, this is something different. It's nothing to do with the AI. So to avoid that, they will actually update the regulation every year, especially with those kind of stuff which comes new, because AI, new stuff is coming in the AI all the time.
Thank you.
And chatbot is a really good example. You need to go to the regulation for the chatbots, because chatbots deal with humans. Yeah. Good. Thank you.
So thank you very much, Raja. That was something really quite different for us, and yeah, I hope everybody enjoyed it. So, moving on, I'd optimistically called this section Any Other Business, but unless anyone has anything they desperately want to bring up at this point, I'll just move to some closing comments. So, I think we've had 4 great presentations today. We've had the value of threat intelligence, we've had compliance on databases, we've had changes in standards, we've had challenges in the AI space. It's a huge breadth of stuff, and this is all things that ISACA covers. So all due thanks to Maggie, Mark, Vernon, Raja for sharing their wisdom, and also I think I should give a shout out to the committee who've all piled together to try and make today possible. And as Alison said this morning, it's our first in-person event in 2 years, and hopefully we'll be getting a lot more of these going forward. And that's not to say that we are necessarily going to neglect online stuff, because this is what makes us available to the wider membership. And I was commenting to one of the RSE staff earlier on, we are a Scottish chapter. Scotland is a little bit more than just Edinburgh and occasionally a trip over to Glasgow. All of the streams of today's events, and I can see that having checked in on YouTube, they have been being watched in the background. They will all be available on our YouTube channel, and I believe YouTube needs a little bit of time just to process this stuff and have it listed as a video. So do keep an eye out for that. Do subscribe to the channel and keep an eye out for future content. I'd like to actually give a shout out as well to Edward Steele back in the booth and the Royal Society of Edinburgh, who helped talk us through how to make this possible and make sure that we knew what we were doing and had everything working in the way it was supposed to. Turns out that YouTube is not as easy as some of the kids today make it look. Probably one of the more important questions, CPE. So members should be receiving CPE certificates in their email over the coming week or so. The automated upload option still doesn't seem to be working in quite the way it should do. So rather than take the risk of anyone missing out on those all-important certification updates, and I know I'm one of those will be coming out for you to self-register through the Engage portal on ISACA itself. Non-members, you are perfectly entitled to claim this event yourself for your own qualifications. You will have to retain your own evidence. Similarly, for anyone watching on the streams or catching up with the videos afterwards, and I use the Dave channel language of, and all of those of you who are watching us next year, please retain your own evidence for that. We can't actually, despite what Google thinks, get any information out of them about who's been watching the YouTube streams. Over the next few weeks or so, the committee will be meeting to discuss new events, new opportunities, and plan what we can be doing to support everyone going forward. We're always open to ideas from members for opportunities, possibilities, things they want to hear about. And certainly with the streaming option we now have available to us, the opportunity exists there to be able to broadcast little snippets of your thoughts to our wider membership. And of course, anything you present, anything you bring to us, that's worth CPEs in its own right for your own qualifications. Last couple of thoughts. So members, if you haven't yet claimed your gift, do catch up with myself or Glenn down at the front to make sure you've picked that up. And for non-members, I hope we've given you an idea today of some of the benefits that can come from being a member of ISACA. I'm aware that not everyone in here is from Scotland. Some people are from other areas. Chapters exist everywhere, and they're always welcome and open to members. But great opportunity to learn about all sorts of things in IT security, IT governance, the whole space. And it's not just about getting gifts at the front desk. So if you're interested and you're not a member, then have a look at isaca.org and have a look at the great resources and things that are available. And final thanks is to everyone here for attending. Hope you've enjoyed the day. Thank you very much.